cover section 8.5, part 3. We're gonna solve example 5, which is asking us to solve a system of equations, a linear system, and we're going to have 3 variables, and this is what we call Cramer's rule. So before we solve the system, let's go over the steps. So what we're going to be doing is we're going to be finding 4 determinants. And those determinants are going to come from, well, here we have the first one. And this determinant, it comes from the elements inside the determinant will be the coefficients of the system. Now the second determinant is going to be formed by the coefficients will be on the second and third column. However, the numbers from the first column are going to come from here, from the constant terms. So what we're going to do is use the same as the coefficient matrix, but we will replace the x coefficients with constant terms. Now the third determinant that we're going to find, we're going to use the same as the coefficient matrix, but now we're going to replace the second column, or the column that on the first one represents the y coefficients. So we're going to replace that column, replace y coefficients with the constant terms. And lastly, the fourth determinant that we have to find, which will be determinant of z, we will use the same as the coefficient matrix, and in this case we will replace the third column with the constant terms. So we're going to replace the z coefficients with the constant terms. Now, once we have those 4 determinants, we're going to find values for x by dividing the determinant of x by the determinant of the coefficient. And what I mean by the determinant of x is the one that we have here, the one where we replace the first column with the coefficients. Now, the way we will find y will be by dividing the determinant of y by the determinant that we obtain by using the coefficients. And finally, the way we will find the value for z will be by dividing the determinant of z by the determinant of the coefficients. And here again, we have to make sure that the determinant, the one that comes from here, from the coefficients, is not equal to 0, because we know we are not supposed to divide by 0. So if we were to find a determinant equaling 0, what that means is that the system has no solution, therefore it's inconsistent. So let's go ahead and get started. We're going to have to find several determinants. That's why I included 2 slides on your handout. So once you run out of space on the first slide, just switch to the second one. So let's go ahead and establish what the matrix for the constant terms will be. Let's call it A. Not the constants, I'm sorry, the coefficients. So that's going to be 1, 1, 2, 2, 4, and 3. Negative 1, negative 2, and positive 1. Now we're going to have another matrix, and this will be the constant terms. And that matrix will be negative 4, negative 6, and 3. The numbers that we have here. So those are the numbers that we're going to be replacing to find determinant of x. We will replace those numbers on the first column. To find determinant of y, we will replace them on the second column, and to find the determinant of z, we will replace them on the third column. So remember that. So let's go ahead and find the determinant. So that's the one that we will find by using the coefficients. So we have 1, 1, 2, 2, 4, 3, negative 1, negative 2, and 1. And in this case, I'm going to use my numerical factors. I will use my first column because I have all positive numbers. I have 1, 1, and 2. Now, just as a reminder, remember that your signs, when you find determinants, they will go like this: positive, negative, positive, negative, positive, negative, positive, negative, positive. So since I am using the ones on the first column, my numerical factors will follow that pattern: positive, negative, and then positive. So first, I will take 1. And remember here, we need to get the determinant, a 2 by 2 determinant, actually. So before I do that multiplication, let's write it down. So the idea here is that you cover the column and the row that contains that number 1. So the numbers that are left will be here for negative 2, 3, and 1. And then following this pattern, we're going to use the negative sign next, and then 1. So now we use this one, and remember we have to cover or cross out the row that contains this 1 and the column that contains that 1. So the numbers that will go inside the matrix will be, the determinant will be here, 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 and here. 2, negative 1, 3, and 1. And then the last one will come from plus 2. So now I'm using this number, 2. And for the 2 by 2 determinant, I will cross out the row that has the 2 and the column that has the 2. And so my 2 by 2 determinant will come from the elements that I circled there. So 2, negative 1, 4, and negative 2. Now we're going to simplify this. So we have 1 times a 2 by 2 determinant will be 4 minus negative 6 minus 1. The 2 by 2 determinant will be 2 minus negative 3. And then plus 2 times negative 4 minus negative 4. So we have 1 times 4 plus 6 minus 1 times 2 plus 3 plus 2 times negative 4 plus 4. So we'll have 1 times 10 minus 1 times 5. And here we will have 2 times 0. So we could say that will equal 0. So 1 times 10 is equal to 10. Negative 1 times 5 is equal to negative 5. So 10 minus 5 is equal to 5. And so this number here is what we will call the determinant of the system, or the determinant that comes from the coefficients. Okay, now we're going to go and try to find the determinant of x. So what I need to do first is to replace the x column with the constant terms. And the constant terms were -4, -6, and 3. Now the second and third column will be the same as the coefficient matrix. So 2, 4, 3, -1, -2, and 1. Now here, there's not really an easy way to find the determinant. So what I'm going to do is just stick to the same idea and take the first column as my numerical factors. So remember the way the signs go for that first column will be positive, negative, and positive. So we will have positive -4 times 4, 3, -2, and 1. That will be the second order determinant that it is obtained by crossing out first row, first column. Then we have -6 times the second order determinant. And that will be 2, -1, 3, and 1. And finally, we will have +3 times 2, 4, -1, and 2. Here we'll have -4 times 4 minus -6. And then negative times negative is +6 times 2 minus -3 plus 3 times 4 minus -4. So -4 times 4 plus 6, 6 times 2 plus 3, and 3 times 4 plus 4. And so we keep simplifying, and we will have -4 times 10 plus 6 times 5 plus 3 times 8, and -40 plus 30 plus 24. And it actually seems like I made a mistake, so I'm going to take a few minutes to check my work. Okay, so I found a mistake. My mistake was here. When I used this cofactor, or the number as a numerical factor, remember I had to cross the third row and first column, so I was supposed to use those numbers, 2, 4, -1, and -2, and so my mistake was right here. This 2 was supposed to be a -2. So I'm going to check my work here. I'm going to correct my work. So in this case, I should have something like 3 times 2 times -2 is -4 minus 4 times -1, that is -4. So that's how I was supposed to get a 0. So we have -4, negative times negative is +4. So I hope you're using a pencil. -4 plus 4 is 0. And so 3 times 0 is 0. So this 24 is wrong. That should actually be a 0. Okay. And so just to finish this one, -40 plus 30 will be -10. Okay, so you might be running out of space, so remember, you could go to the next slide if you need to. Can we do that? So now what I'm going to find is the determinant of y. And remember, we're going to use the same as the coefficient matrix, but in this case, we are going to change the second column with the constant terms. And so remember, I'm changing this with -4, -6, and 3. So as you're working on your homework and you take an exam, I think it will be important for you to be checking your work. So let's see. What I'm going to use here as my numerical factors will be the first column. So we'll have +1 times the 2 by 2 determinant made by the elements -6, 3, -2, and 1. Then we have -1 times the 2 by 2 determinant with the elements -4, -1, 3, and 1. And then we have +2 times the 2 by 2 determinant that comes from -4, -6, -1, and -2. So the 2 by 2 determinant here will be -6 minus -6, -1 times -4 minus -3. Remember, this minus is part of the formula of finding the determinant. +2 times -4 times -2 will be +8, minus -6 times -1 will be +6. So we have 1 times -6 plus 6, minus 1 times -4 plus 3, plus 2 times 8 minus 6 will be 2. This is 0, so I'm not even going to bother with that. From here, I will obtain -1 times -4 plus 3 is -1. And here we have 2 plus 2, which is 4. So -1 times -1 is +1. So +1 plus 4 is equal to 5. And so that's how we get the determinant of y is equal to 5. So remember, we still have one more to go, determinant of z. And so now, in this case, I will use the same as the coefficient matrix, but what I'm going to change will be the third column. So I'm going to replace the coefficients of z with the constant terms. And the constant terms are -4, -6, and 3. And so let's find the determinant now. So again, I am going to use the first column as my numerical factors. So I have 1 times, well, I'm getting a little bit ahead, the 2 by 2 determinant that will come from 4, -6, 3, and 3. And then we have -1 times the 2 by 2 determinant that comes from 2, -4, 3, and 3. And then we have +2 times the 2 by 2 determinant that comes from 2, 4, -4, and -6. We have 1 times 12 minus -18, minus 1 times 6 minus -12, plus 2 times -12 minus -4. So we have 1 times 12 plus 18, -1 times 6 plus 12, plus 2 times -12 plus 4. 1 times 12 plus 18 is 30. 6 plus 12 is 18. And finally, -12 plus 4. Okay, I might have made a mistake again. I apologize for that, but it's Saturday and I actually want to be home right now doing nothing. So again, my mistake is here. So 4 times negative 4, that should be a negative 16. So here, I should have a positive 16 instead. So please correct that again. I told you to use a pencil, so I hope you're using one. So we have 2 times 12, negative 12 plus 16, so that will be positive 4. 1 times 30 is 30, minus 18 plus 8. And this will equal to 20. So now we have our fourth and last determinant. So the determinant of z will be 20. Okay, so now the final step is to find the x, y, and z values. Remember, for this one we need determinant of x divided by d. For y, we will need determinant of y divided by d. And for z, we will need determinant of z divided by d. So the determinant of x was equal to negative 10. And the determinant is equal to 5. So that will equal to negative 2. Determinant of y is equal to 5. The determinant is equal to 5. 5 over 5 is equal to 1. Determinant of z is equal to 20, and determinant is equal to 5. So 20 divided by 5 is equal to 4. And that is the end of that problem. So I believe we got enough practice with how to find 3 by 3 determinants. So for the last problem, before we get to it, we're actually going to find a determinant of fourth order of a 4 by 4 matrix. Like, it's actually going to be pretty easy. So let's just write a few statements here. So we have that an n order determinant. That's just to represent. It could be second order, third order, fourth order, or fifth order, or so on. So an nth order determinant is said to be the determinant of a matrix with n rows and n columns. Remember, determinants can only be found in square matrices. The value of an nth order determinant when n is greater than 2 can be found in terms of determinants of order n minus 1. So just like we did with the third order determinant, or the 3 by 3 determinant, we had to use a numerical factor, and then we were using a 2 by 2 determinant. So something like that. So that's what it means. So if we are looking for a fourth order determinant, that makes sense that we will find it by using 3 by 3 determinants. And if you notice, before you get all scared and start complaining, we're going to be using that column that I just circled as our numerical factors. And why? Because that contains 2 zeros, so that's going to save me some work. But let's go ahead and finish the statements here. So the minor of the element A sub I j, with I representing the row, j representing the column, is a determinant obtained by deleting the I row and the J column. So let me give you a quick example. So if I'm using that as my numerical factor, then we will, this is the entry that it is located in the first row, third column. So we will eliminate the first row and the third column, and so the minor, what it says here, will be the 3 by 3 determinant that comes from this numbers and this numbers here, like -1, 0, 2, 1, 2, 3, 2, -3, and +1. This is what will be the minor. All right, so let's go back to the definition in the given array of numbers. If you do not understand what I just said, feel free to rewind the video. The cofactor of the element so I forgot to write something here. So the cofactor, and the cofactor refers to, it's going to determine what sign we will use for the numerical factor. So the cofactor of the element A to the, in the ith row, j column is -1 to the power I plus j times the minor of A sub ij. So just quickly here, let's go ahead and determine. We already know what the element is here, the minor. So remember, we were talking about that using 3 as our numerical factor. So to determine what sign we will need, so the numerical factor was three. And 3, we already established, is located in the first column, third row. So if to determine if 3 will be preceded by a +1 or a -1, you could do this. So you have -1 to the power, coming from here, 1 plus 3. And it is pretty obvious that we're going to get an even number as the power, and as you should know by now, -1 raised to an even power will always be +1. So in this case, the cofactor will be preceded by a positive sign. But I know that you're always asking, is there an easier way? So yes, of course there is. And so the easier way to determine the cofactor, or the sign that will be preceding the numerical factor, you can follow this pattern. So you always start with positive, then negative, positive, negative. And I'm doing this for a 4 by 4. So the next column will be negative, positive, negative, positive, and then positive, negative, positive, negative, negative, positive, negative, positive. And if you are going to study, perhaps computer science, you know who you are, make sure you do pay attention to little things like this, because like I said, matrices are so important in computer science. And if you have to ever design a program that will have to check some entries or some data, then you might want to, appreciate what you're learning right now by paying attention and not complaining. All right, so let's go ahead and just get this over with. So I already told you that I was going to be using this column as my numerical factors because I have a 0 and another 0. So I'm going to find a fourth order determinant, or the determinant of a 4 by 4 matrix. So again, based on that definition, I'm going to be using 3 by 3 determinants to find it. So I start with my cofactor of 3. And remember, 3 will have a positive sign in front of it. And then my minor, remember, we have to cross out the column that has the 3 and the row that has the 3. So then the minor will be -1, 1, 2, 0, 2, and -3. Then 2, 3, and 1. And we move on to the next one. The cofactor will be 1, -1. The numerical factor is 0 in this case. Oops, I'm sorry, I need -0. And the minor, I don't care, so let's just not even bother doing it because we know it's going to equal to 0. Same thing will happen here. If my numerical factor is 0, then the whole product will be 0. So I'm just going to skip those 2 steps. I don't need to do that. So now I'm going to move to my fourth numerical factor, and that is a -4. So before I start writing, I need to check at my cofactor, the one that determines the sign, and that is negative. So I'm going to have minus -4. And then, of course, I need my minor, which will be the 3 by 3 matrix. And remember, we need to cross that column and that row. So the minor will come from the numbers that are left there. So it will be 1, -1, 0, -2, 1, and 2, 0, 2, and -3. And so, since I already showed you several times how to find the determinant of a 3 by 3 matrix, I'm going to skip that step. And I'm going to tell you that the answer is -25, the determinant of this one. Here I have negative times negative, so that would be +4 times the determinant of this 3 by 3 matrix, and that is equal to -1. So 3 times -25 is -75. 4 times -1 is -4, and so this will equal to -70. Now I check on my math lab, and you do have 2 questions that involve a 4 by 4 determinant, or a determinant of 4th order. So, I mean, it's not a lot of work, but I know you can do it. Just take your time. I will make homework for section 8.5 due on Friday. Yes, Black Friday. 8.1 will still be due. I'm sorry, not 8.1. 8.3. No. Yes, 8.1 will be due Monday or Tuesday. 8.4 will be due Wednesday. And 8.5 will be due Friday. Okay, so I wish you luck and happy Thanksgiving. Make sure you do work on your take-home exam. Don't leave that until the end.